So, good evening to all. Welcome to our very first webinar from the Brussels branch of the Royal Aeronautical Society. I hope you all find an easy way in. It's the first time we're using this tool, but looks like an interesting and easy to use tool as well at the same time. We just closed the poll, which is interesting enough, giving us about 52% people answering yes and 48 no. So let's see if that changes after the presentation. The way we'll go today is I'll have a short introduction first. Then we'll introduce Jeff Dalton. He will be presenting us Air-Race E. And then throughout the presentation, you can already, if you have any questions, you can already answer them just by writing. And there's somewhere in the panel that you have in front of you a way to answer questions. We will take them afterwards. I will see them here popping up on my screen, so I can kind of collect them and pose the questions after the presentation. This session is also recorded, but none of you is visible, so just for you, good to know. After the presentation, then I will unlock the mics, and then everybody can unmute themselves, and then there will be a chance to have verbal questions if you have any for Jeff and his team. So let's start with that. Just not sure if you were aware that air racing overall is not since yesterday. It's actually more than a century old. It all started already in 1909. Think of it, that was in France, in Reims, where also then Glenn Curtis and Louis Blériot, two well-known names, were racing against each other. You can check it out on Google and you'll find out who won. Few people at that time had ever seen airplanes, so let alone see an air race, but it actually inspired most people already of what aviation can bring. So also the sport and the spectacle of meetings and actually were a great instrument at that time to raise the popularity of aviation in those first decades of the century. Now, moving along, we all know that Red Bull had been another, and also Air Race 1, of course, but Red Bull was another way of bringing air races to the public, where 2002, Peter Belenier, Hungarian, well-experienced aerobatics pilot, came up with the idea. 2003, they started, and actually in 2005, they started their first official race. I still have my own CD about that. Very interesting. And the 1909 and so on, it's still in my office. So people who've been in my office before have seen that plaque. So, well, even without knowing it, I'm already quite into the things now. Another interesting thing that you may not know is that the one of the aircraft that became very famous as well in the Red Bull Air Race was the Edge 540 from the company Zivco. But I'm not sure if you all know the background of the Zivco company, Zivco Aeronautics Incorporated. It's a small woman-owned business, by the way, very specialized in advanced composite materials, design, prototyping, manufacturing, and they only do that aircraft as a side anyway, but it helps them to be a very good, well-experienced composite company. Now, anyhow, air races are with us for a long time, but they are more than just a race. They are so much more. So they inspired the people and, of course, the crowd, but also the people who are competing in the teams. And their competitive drive and their fixed agenda, the fixed agenda for sure when they plan to meet and compete, makes them actually very, very focused on getting the best out of both man and machine. And so that hunger kind of brings them and that drives them to really innovate and get the best out of everything to win the race. So the stakes are very high, and that drive probably also brings the best out of what we have in our brains. So let's listen to Jeff Dalton. He's a passionate aviator and entrepreneur, set up also Air-Race E as some of the other things that he will be presenting today. So without further ado, I'd like to hand over to Jeff, and when the tool should allow me to do so. Just trying to get it all organized here. So Jeff, the floor is yours.
Okay, excellent. Thank you, Yuri. Is my camera working okay? Am I on there? Oop, sorry, Yuri. There we go. Okay, sorry about that. There's a few buttons here I have to refamiliarize myself with. So again, Yuri, thank you very much, and thank you to the Royal Aeronautical Society and everyone who's attending today to to hear about AirAC and what we're doing. It's a very, very exciting project, and I'm really delighted that you all have taken the time to learn more about us. So yeah, I mean, as Yuri said, I'm Jeff Zaltman. I'm the founder of the sports series of the company, and here to tell you all about AirAC. And if you'll give me just a moment, I will bring up my presentation for you. And I hope everyone can see my screen now. Hopefully that's working fine.
Yeah, we see your control box as well, Jeff.
Okay. How about now? Oops. Apologize to everyone. This is a nice, powerful app, but it's got many features for me. Is that better?
I think it's okay.
Okay, great. So yeah, so again, AirAC is quite simply, in a nutshell, the first electric airplane race. This is, it's a really, really innovative, progressive project that is involving a lot of people. Of course, it's not just our company. And we're going to kind of walk you through the whole experience of AirAC and what it is. I should mention the first race. This is something we're developing now, and we'll tell you all about the status of where we're at. But the first race will be already at the end of next year. So in December 2021, perhaps a little bit sooner. In fact, we've got some options for a race in October, November. We're going to be seeing actual electric airplane racing. Now, our mission really is to create a platform to accelerate technological development in electrification of aerospace and electric mobility. So that's really our fundamental goal. We are here to help the industry develop the technology and also, of course, communicate its intentions and ambitions to deliver greener aviation to the world, all while enjoying a very exciting motorsport. So it's a classic sport event, just like any other, on top of being a technological platform. So as Yuri pointed out, and grateful for that recognition, that motorsport has really always been a platform for technology development. So throughout history, it's played that role. Of course, we're very familiar with Formula One car racing, obviously motorcycles, boats, and a multitude of other car races that we can all name. It runs the gamut, and all of those really have been in some form or another a forum for the technology development. And actually most manufacturers in automotive and in those other industries, again, boating or motorcycles, have actually played a role or entered in some capacity into these motorsports to develop their products and bring those products to market. So that's really the ultimate goal, is not just testing and innovating, but actually to have those products work their way into consumer markets. What you see on your screen there is just a quote from one of our teams, actually, which is also an aircraft manufacturer, Equator, based in Norway, and they are doing just that, as are other teams. They are using this their experience in AirAC, their whole development process and the life cycle of the R&D and the learnings from the races, to take those learnings and incorporate them back into their ultimately into their their products. So this is really, really, really exciting for us, and to have the market see that. So yeah, I mean, air racing's been around for over 100 years. Most of you, probably know that. Yuri just mentioned that. It's had taken on many different forms. It's been around since just about any other motorsport, and it is a motorsport itself, of course. And during its life cycle of air racing for the past 100, 110 years, it has actually also been very much used as a platform for bringing technologies to market. So there are many examples. The image here you have of the Spitfire, perhaps one of the most famous examples, certainly one of the most famous aircraft of World War II, if not all time, actually came from racing. It was first a seaplane racing in the Schneider Trophy in the 20s and 30s, before war ever became a topic. So, that technology that was that these companies were investing into air racing actually became very, very important in all of our histories. And that was the heyday of racing, 20s and 30s. It was a heyday of air racing because it was a heyday, an important era of technology in aviation as well. And that's where we feel we are again today. Now, there's another sport here, I mentioned it on the screen. It's called Formula One air racing, and that's a very exciting sport. It's also been around for over 70 years. The three logos you see on the bottom of your screen are the sanctioning bodies, the governing bodies for the sport. It started in the US, worked its way into Europe in the 70s, and has been running races ever since. And this is a very, very prolific and prominent and important form of racing, especially because it's a formula. And I'll come on to why we're talking about that. So Formula One airplane racing is actually currently going. It's a common and popular sport right now. And our organization is actually organizing these events. So we are organizing them under the brand name Air Race One World Cup. And we've been doing that for about 6 or 7 years now. And we've organized races in China, in Thailand, Tunisia, Spain, the USA, and elsewhere. And we've been promoting these events and had quite a lot of success, bringing it out to new markets. So that the sport of air racing in general through Formula One air racing is actually expanding, in a really solid way, even prior to our next phase of electric air racing. I should mention that what's interesting also about Formula One air racing is that these are the only airplanes that are actually built just to race. Most of the other races that we've been familiar with over time have all taken airplanes that were built for some other, purpose, another mission, and repurposed for a race of one or another format. But Formula One air racing and Air Race One is interesting because the planes are only built to race. That is their fun. That's their only mission. They go around in an open circuit and they go fast, and that's because they're built to the formula. So that is what they do. And again, that's a very, very integral component of why we're talking about it now. So if I can take this moment to ask Yuri, I've got a quick, very short video, less than a minute. If you're able to play that from your end, Yuri, just give you guys a taste of what we do.
the other video as well, Jeff?
Oh, there we go. I think I should be back now. So let me move this forward one. Oops, there we go. Okay, thanks, Yuri. Okay, I hope you can all see my presentation again. So yeah, so that hopefully gave you just a quick snapshot, a little flavor of what we do in our current format of air racing in the Air Race 1 World Cup, which again is the Formula 1 air racing. Now, as you can see here, this is kind of a simple diagram of the race course. As you saw in those videos, our planes are racing side by side. So in this formula sport, the planes race all together. They take off from the runway. 8 airplanes start together in a starting grid, much like you would see in a car race. Wave the green flag and they take off, and they are racing from the beginning, from the runway. They go around 6 pylons and perform 8 laps. The first one to cross the line wins. So this is direct, wingtip to wingtip flying, direct racing. Obviously, you guys are, of course, familiar with the Red Bull Air Race, which does did, I guess, but a fantastic race. They did a very exciting sport, but this is quite different. So their race was a single plane at a time, doing effectively a time trial, an aerobatic time trial. This is 8 airplanes racing against each other, and this is what makes it particularly competitive. The comparison is immediate to everyone. You can see the whole race right in front of you, and you can, there's winners and losers, and you can see the positioning of everyone. So it becomes very, very, very competitive. And the other interesting point to reemphasize is that it's competitive because they're all racing to a formula. And that means that there's a set of rules that the airplanes and the teams use to build their airplanes to the formula. But there's a lot of flexibility in how they configure, or how you say sort of connect the dots of the criteria for the race and design your plane. So the outcome can be quite different, which allows for that innovation. Yeah, so this is the basic idea of the format of the sport. As I mentioned, we've been around the world, but not only doing our races, but doing on TV, on media. We've been in over all of the events we do now. We're in over 100 countries on television. We have quite a lot of success in the media. This is important. This isn't us just saying, hey, we're really great. This is saying that air racing, not only are we making the case that it's a great technological platform for the industry, but it is a great consumer event. And Red Bull Air Race, of course, went a long way in proving that it is a great marketing tool, and that fans can really enjoy this as a sport. So we're demonstrating that with our format as well. So that's very reassuring, and that actually would also be very interesting to the industry. So this media coverage is part of it. It's about not just technology, but communicating the efforts that aerospace is making towards the end of greener aviation, and also not to mention cities and other stakeholders. Now that brings us to, more specifically, to Air Race E. So it's really off the back of the success that we've had with Air Race 1, and this is why we went into all that information about Air Race 1. It's off the back of that success that we realize we have the opportunity here of a generation to really take air racing, and therefore aviation, forward into the next generation by going electric. We can take it into the future and into the, as I said, into the next generation, all while both serving the industry, the aerospace industry and the technology, the mobility industry in general, as well as entertaining fans. So I mentioned there in the first bullet point that, again, this is why we talked about the Formula 1 air racing, because we are basing Air Race E on the exact same format. So it's identical. It really is the very same format of Formula 1 air racing. 8 airplanes racing around an open circuit. First one to cross the line wins. And that is great because we're not really reinventing the wheel. We're building on something that has a legacy. But of course, we're converting it to electric and electric propulsion, and that's the element we're changing. So it really is a perfect test bed. That's really our focus again, is accelerating the technology in the industry. And a lot of you are probably familiar with Formula E, which is the electric car races. Very, I guess you could argue, comparable to Formula One car racing, but it's of course electric, which has had some amazing successes in the past 5-6 years that it's been going. And they're doing great things. And we are very much emulating Formula E. So we're doing quite literally the same thing for aerospace that Formula E is doing in an automotive. So a very, very similar model. And in fact, we're, we have discussions with them. There might be some great collaboration. So there's a lot of great transfer in between those two. So it's an exciting time for all electrification in transport, but in particular, we think in aviation. So again, I would like to mention that it's important that we went through the Formula One side of things, because actually we're bringing that forward into, again, the next generation of aerospace. The importance of that is that we have all the tools, we have all the sort of ingredients that an organization needs to actually develop air races and to build air races. We, by having been the official promoter of the Formula sport, we've got obviously training and qualifying systems in place for pilots and teams. We've got cities, media, race operations, safety personnel, the sanctioning bodies, very important that there's a third party observing the rules and how things are done and judging. So all of that stuff is possible because of our experience in our existing sport. What's missing, of course, are, as we showed here, the technical partners. So it's the electric tech partners that's the kind of missing ingredient, and that's why we're inviting the industry to get involved. So we're offering kind of a real-world mission for industry partners to come in and prove themselves. And this is, so that's again where the industry can fill that gap and have a place in this property. And it's extremely important that it's an open platform. So we are very, very strict that we hope that all and every company in the industry will be able to have some role, some participation, some stake in this game. So we really want it to be an open platform. It's not just competition on the pitch, on the racing circuit. It's competition in the technology. And so every airplane in the series could have different power plants, could have different motors, different inverters, different batteries, even different configurations to some extent. So that's really important that we can showcase and contrast and learn and collaborate within the industry and demonstrate that. You can see some examples of some of those areas. It's interesting because it's a formula. We actually we write the rules and they build the planes to the formula. So we really can test the entire aircraft or any of those areas that we want. So the rules are written specifically with the industry output in mind. What does the industry want to build and test and sell? And that's how we write the rules. And these are, again, some of the examples of the partners that might find it interesting. And to help validate our concept, we were delighted that Airbus came on board a year or so ago. So Airbus was kind of the first OEM or first manufacturer to say, hey, we get it, we see this, we understand that this can help take concepts to the market. And while Airbus is, looking at building aircraft, large aircraft to carry passengers a great distance in 30 or 40 years by electric power, they're hoping to shave 10 or so years off it. They've claimed that they will be able to in 30 years or whatever the horizon is, to be able to draw a line back to their participation in Air Race E in terms of the lineage of that technology. So they'll be able to trace that back to what they're doing here now with us. So that's an exciting validation of everything we're talking about. And Airbus, I should mention, is a series partner. They're not specifically building a team, so they're not going to be racing as, per se. They're there to nurture the series and to help all of the teams with lessons learned and perhaps some industry research, and to share ideas and collaborate. So they're a really, really, really great facilitator of the series and enabler of the series. And so are a great many other partners. Won't even linger on this slide too long, because there's actually quite a lot more interested stakeholders in the system, in our ecosystem. So in ARAC, we've got partners, we've got sponsors, we've got developers, suppliers, there's team partners, and universities building prototypes. Lots of activity going on in and around our series at the moment, quite behind the scenes. And of course we're growing, so we've got a long list of other interested stakeholders, and like I said, it's an open platform. So for us, it's all about getting everybody in so that we can make this the most effective possible. Now, we've mentioned formula a number of times. It really comes down to what are the rules. Like I said, the rules have to make sense not only on a capability point of view and a realistic point of view and a safety point of view, most of all, of course. Sometimes I don't say that all the time because it's kind of obvious. I mean, safety is all of our in this industry the highest priority at all times. So 80% of what we do is about that. But it's about where do we want to drive this technology forward? What does the industry want? And what are its targets in the market? What are the time frames? Where does it need to develop? So ultimately, our rules must lead to products entering the market. As you can see here, a few bullet points, fairly simple. The rules start from the Formula One air racing point of view. We have capped the power to 150 kilowatts. So that's the power of the motor at charged 800 up to 800 volts. There's a boost. So for a period of 30 seconds during the race, they can actually boost that up to 175 kilowatts. But again, which motor and what configuration, and is it 2 motors, 1 motor, etc., that's down to the team. Now, a big difference between Formula One air racing here is that the race is 4 laps. Now, doesn't sound like much. Of course, it is quite a bit for the endurance of a plane, but this is what allows us to do this now. A lot of, we see some light aircraft, in electrification coming into the market on the training side, but most of us think of electric propulsion as kind of a longer horizon, longer term prospect. The reason we can do this now and race next year is because we only need about 5 minutes, well, really 10 minutes of endurance, but about 5 minutes at full power. So that's achievable even with today's technology. It's really about how that's configured and how it's how the energy is processed and how the output is managed to really develop that. But of course, people will be adding newer and newer technologies into the mix, and the race will be getting longer, of course, in time. So we can go into a lot of the topics about the weight and what we expect the charge to be. I mean, at the moment that the teams can configure the battery to be any size they feel necessary. However, we are insisting that they have a reserve battery, which is automatically triggered should the power level drop to a certain amount before they get across the finish line. So they will, if that happens, they will be immediately disqualified, and again, the reserve battery will be triggered automatically, and they will be instructed to land. They will know to land, and they're out of the race. So there are a lot of safety precautions, which are also very interesting developments for the industry that we're incorporating into the rules. And the rules are available; they're publicly available, so you can either contact us or go to the website and actually get in touch for the rules. And perhaps some of you in this audience will even join with the team, which we very much welcome. Speaking of which, good timing to introduce some of the teams. We have teams from all over the world, mostly Europe and the US at the moment. We have some teams even in Asia coming up, and some really exciting places that we might not even be considering as sort of technological leading markets. But everyone's finding this very interesting from all walks. And these teams are, in most cases, very, very accomplished engineering teams, and often manufacturers, or they're working with manufacturers to develop their technologies. And they all have, of course, what they would refer to as the best concept and the best configuration for the race, for a race plane. But they're all very different. And it's really refreshing, really exciting dealing with them. We're in communications with them regularly. We collaborate quite a lot with the teams. It's important perhaps to mention that we actually bring a lot of really good deals to the teams. So the industry is very, very supportive of what we do, not just on a partner level, but actually getting kind of discounts or special access or training to the teams, and the industry is really coming in to support these teams. So they're really actually in a very kind of, if I could say, sort of luxurious, privileged perhaps position, and that's really rewarding for us that we can offer the teams that. And these teams are developing. There are actually some more teams coming online. Like I said, we just haven't sort of announced them yet, and they're going to be coming down the line and racing next year. So you're going to see a lot more about that soon. This is just a quick sort of snapshot of actually one of the teams that we, Condor Racing, that we had invited to Dubai, because they were the first team to have sort of built or configured an actual race plane to the formula. A lot of the other teams were testing in various levels of testing and development. These guys had actually configured the plane and the powertrain. So we were invited by Airbus to the Dubai Air Show to unveil this aircraft, and it got a huge amount of success. In fact, the local media told me at one point that it was the most shared news of the entire Dubai Air Show. So that was really exciting. So that, this isn't just kind of fun little, toy airplane. These are, the industry knows what this means. They know the impact that this can have, and they're very keen to see it flourish. Now, Yuri, if you don't mind, this is another moment. I'm actually going to wrap up with another very short video just to give you a snapshot of that occasion. If you want to just play a very short video.
This is a really, really exciting moment for us. We're here at the Dubai Air Show to showcase the first ever electric race plane. So racing around an oval circuit around pylons, all 8 planes together, passing, weaving, winding. So it's pure motorsport and real racing.
We help building up a whole ecosystem around electrification. It can be picked up by our urban air mobility or even scaled by our bigger Airbus airplanes.
This is a really, really exciting beginning. It's about developing the technology and changing the world as we do it.
Okay, so thank you very much. So I think I'm going to, just go to this last slide to again say thank you everyone for listening to me, and hopefully you'll take some inspiration or interest or curiosity at least in some of the things that we've been talking about and that we do here. And we are very, very, very welcoming to anyone to come on board and collaborate in lots of different ways. So I'm going to be available now. I think Yuri's allowed some time for for you guys to ask some questions. I'll hand it back to him and leave it to you for the moment. Thank you.
All righty, so I've unlocked all the microphones, so anyone who has a question, feel free to unmute yourself and pose a question. I have already recorded one through the questions box. So Jeff, your screen is freezing up.
Oh, how's that?
Yeah, it's coming back, right? Maybe you could stop the presentation from your side.
Oh, I see. Let me,
So before we go into the questions, maybe let me first introduce myself. So I'm the chairman of a lucky chairman, I must say, of a very good team of the Brussels branch of the Royal Aeronautical Society. So we're very kind of happy to have you all here. As I said in the beginning, this is our first webinar. So playing around with the tool. We all hope you enjoyed that one. We have as well, of course, as you saw before, Jeff Southman. I'll be happy to answer any questions together with one of his more technical colleagues, Isan Paris. So there is I think hopefully a good panel for any questions you may have. The one that already came through on the panel here was, and I'm reading it off here from the other screen, so that's why you see me look in that direction. So currently, electric propulsion is well suited for light, energy-intensive, short-duration flights, therefore perfect for air racing. Can you expand on how that is going to contribute to the development of electric propulsion for heavy endurance, long-duration flights needed for commercial aviation?
okay, well, actually, thanks for that question, because that is the fundamental question to ask. You know, how does this actually do what you're saying, Jeff? So that's a good question. It's also a question that I will take liberty of passing to Ethan, because let me introduce Ethan in more detail. He's an aerospace engineer and experienced member of who's joined the team last year. Who's helping us bring the teams together and kind of all the constellation of interested parties, pulling them together, as well as to form teams, but also as well as pulling in partners and manufacturers to the industry. So actually, he's having that sort of conversation on a daily basis with manufacturers. So if Ethan, you don't mind, maybe you want to answer that question?
Sure, yeah, absolutely. No, let me thank everyone before doing so. Yeah, thanks, Jory, for organizing this webinar. That's fantastic. So in short, I'll just summarize basically that there's different approaches the industry is taking for the future of electric flight at different scales. And of course, as you very well outlined in the question, I mean, currently, like the performance of electric aircraft is limited, sadly, to light aircraft and short duration applications. Having said that, I mean, we're already seeing a direct transfer of the technology that's being considered for the race environment into commercial applications that have a much larger or longer duration, which are endurance, which is the key factor here. So, for example, the key some of the key elements, of course, I mean, in any kind of electric architecture idea, whether it's hybrid electric or whether you're using fuel cell, or basically like however you organize the source of energy, there is basically more than half of the architecture actually is going to be focused on the efficiency between your inverter, your controller, your thermal management on those components, and that is irrelevant of whether you use a battery or you use a like a conventional internal combustion engine to be like generating electricity, or you use some other sort of energy source. So the teams working with us are actually like looking at that particular like very demanding application where their motors need to be performing at its best during 5 minutes. They're gonna overheat. They're gonna be able also to optimize not only the hardware layer but also all the software and controls around it to actually manage that energy balance and distribution and how like these elements interconnect, and that's very valuable for any scale of commercial electric application.
All right, so I hope, Bernard, that was a good response to your question. And now for everyone, the microphones are available now. If you unmute yourself, feel free to ask any questions. Maybe a question I can ask. So from the poll in the beginning, so we asked if you would consider us air racing as being a, how can I phrase it properly here? So if you had the thought that air racing could actually be a technology development platform, so it was about half the response. So I'm not sure if any of yours have now changed a bit of view on how air racing can actually help in stimulating innovation in these markets. So anyone has a question to see if the technology works well?
And of course, we're happy to take questions off topic as well. Anything that you're curious about in RAC or what we're doing, or feel free to ask.
Mm-hmm. Another question maybe for myself, for you, Jeff, maybe Ethan, you can help responding as well. So when you first started, you had an idea of what the electric power can bring to aviation and how much of a fun that can bring for an air race. Has your view changed now that maybe technology has advanced a bit and maybe also you see further improvements ongoing?
Yeah, it's kind of an interesting question. Thanks. And I must confess, first of all, I'm not an engineer, and I had not been really concentrating too much on electric. I mean, it wasn't like many years I've been wanting to do this. I've been focusing on air racing in general. So I'm kind of the air racing guy, not necessarily an electrification guy. But I was actually approached by the market by a number of different manufacturers of electric aircraft, and they would approach me and say, hey, you're doing all these air races around the world. We build electric airplanes. Could we race our electric airplanes? Could we set up a series with our plane? And I was very interested. I wanted to help, and I thought it was kind of an interesting idea. And after a number even had actually approached me, of course I took it very seriously in each case. What I realized though was in each of those cases, having the aircraft manufacturer race their own planes against their own planes doesn't really prove anything. It doesn't really drive anything forward. It can be an exciting communication of where electrification's at, but it's not really going to do anything for the industry. So what I realized was, well, wait, why don't we take all these different manufacturers that are asking that they want to get into air racing and just have them put one plane and not 8, and then we'll race them against each other. Now we're seeing some real development. So as soon as that clicked 2-3 years ago, it was about 2 months before I just had to do it. I was like, we've got all the tools. There is an interest. There's a reason to do it, and everything that I just went through in my presentation kind of fell into place. Probably by the time I was done with a coffee, and I was like, I just have to do it. And within a couple months, we had announced it, and we had a plan, and it wasn't too long after that we had Airbus on board, and it was all really rolling. So really exciting times, but I wasn't like a long-term veteran of this industry. It was much more recent, but now I'm immersed in it. It's all I do. This is our full-time work. So. Okay.
I got a list of other questions here. So apparently maybe something wrong with microphone, or people prefer to just type it in. I will just read it off. What is your level of cooperation with the Reno air races in the US?
Good question. Reno is a huge part of air racing culture and the history of air racing. It's been racing for 55, maybe 57 years. I think this was supposed to be its 57th year. Sadly, a few days ago, they said that they're having to cancel for the obvious reasons in the world. That was just announced a few days ago, last week, I guess. So we work with them. They're friends of ours, they're collaborators. We have actually done even Air Race 1 events there. We've worked, of course, Formula 1, the sport that I told you has been around for over 70 years, founded the Reno races. It was the first actual race there. That and the Unlimiteds actually started the Reno air races. So we work with those people that actually have been a part of the Reno world for a long, long time. And we're just taking it around the world. There's no official relationship. Reno's its own event organizer, but we do the everywhere outside of Reno. And in terms of electric, they're very keen. Of course, they want to support anything that's air racing. And we have a really good relationship with them, and we're exploring that and perhaps mix it up with a new class. It is a new class of air race. So yeah, it's a really good, where you could, sort of one and the same in many ways.
All right. I got a list of more questions to come here, so be prepared. One question here, is there any way to push the recharging technology?
Very good point. Very good point. Yeah. So in fact, one of the aspects we're looking into, because of the format of the sports, actually the teams are racing multiple times a day. So recharging is part of the equation. Is at the moment something we're going to be controlling more as an organizer. So we'll be, like providing a standard for all the teams to be equal. But for sure, that's an area of development that many companies are getting into for aviation, because there's, there's a lot of areas that need to be considered differently than other types of mobility. And yeah, certainly is going to be a lot of innovation there, not only in times, but also like safety and operations, which are to an extent inexistent today.
All right. So next question, it's a whole response anyway. So very interesting. Thank you for the presentation. You draw parallels between the Air Race E and Formula E. So other than electric car development, Formula E has really progressed the electric vehicle sustainability agenda. Does Air Race E have a broader goal on climate change and sustainability?
Yeah, well, really great point. We get kind of sometimes into the weeds about the technology and something you can hold in your hand and a plane and kind of the fun stuff that we all like in the engineering side. You're right. Formula E has started a number of initiatives, and they do a number of things off the circuit, away from the racing course and away from the technology to create awareness. They do a lot of environmental campaigns. They also do even fun stuff like video games, to reach out to younger audiences. So we absolutely do, and we're actually working in some of those areas, both in online interactivity and gaming, and as well as with the cities that we go to. We're in discussions with numerous cities. You're going to see announcements coming down over the next few months about the locations. We have community outreach programs with those cities, which again we'll be able to tell you more about later. So yeah, so that's all very important. It's about the story and conveying that to people as well, not just the technology. And that's why it's important that it's also a motorsport. It's fun to watch for fans, that it can actually reach out to the community. So it's not just for the industry, it's equally, and the long-term growth of it will be to a live spectating audience, hopefully to progress that. If I could add maybe one example as well, is Airbus has a particular requirement that they want to have renewable energy used in the series. So we're just like, to Ethan's previous point, we're just recharging the planes, plug them in, they charge up. That's a technology exercise. But where do we source that? What are the other implications of it? What are the costs of getting the energy there? Cost to the impact to the environment, and all those other questions. So we are looking at all those aspects of it, which is fun. It's really a great process.
All right. Just for the fun of it, I'm just saying, maybe I'll switch off my camera because I have to look in this direction all the time, so I may distract people. But I'm reading off the other question then. It would appear to be a very dangerous sport with little margin for error. Has there been any fatalities?
A very fair and very important question, and it is indeed. There are elements of danger. It's a dangerous sport, as is all motorsport and all forms of air racing. There's clearly an element of danger. I would not sit here and tell you there isn't. What we do is we mitigate the danger as best as possible, and we think to a very, very exceptional and high degree. And we do that by working with those sports associations. So, for example, the Formula One Air Racing Association, and FARA, which is based in the UK, the Formula Air Racing Association, which is over 50 years old, actually 50 years old this year. We work with those associations and those bodies that have developed and evolved rules for the sport of air racing in general, regardless of the powertrain, over, of course, tried and tested over generations and hundreds of races. So we use their body of rules, which is why we're not trying to invent a new sport. We're basically converting a sport, an existing sport, and then tweaking it for the technology. So we do a lot of that, and even aside from the potential human tragedy of the rare likelihood of there being an incident, it would bring down electrification and aviation and our business and everything else with it. So that is absolutely at all times our utmost focus is safety. It's motorsport. There's always going to be an element of danger, and we minimize that through great work with not only the governing bodies, but the governments and the regulatory bodies and the airports, and the qualifying and vetting of the teams, of the pilots, and how we pick them and how we train them. And with the electrification will come another element of unknown, uncertainty, and safety. And that is actually one of the great benefits we can bring to the market, is we can, given the risk profile of our teams and ourselves and our sport and our ability to work in that dangerous environment, we can actually learn a lot and test a lot, improve a lot on not just technology, battery composition and temperatures, but on operations procedures, things like that, charging, how to charge, where to stand, all those different types of aspects about the holistic view of safety. We can learn that in our controlled environment and carry that out also to the main market. So again, that's a contribution we can offer rather than something we should be afraid of. But great question.
All right, I have a question related to it, and the system just gives me a bit of a headache now, but we get there. So how is safety managed beyond the backup battery presented? Could the teams push too far?
Yeah, you know what? Not only could they will. We're counting on that. That does happen. So that is exactly what we have to inhibit, and it's a lot of effort to find that inhibiting point. A team will make a decision. If you're racing and you're out of power, or you think you're going to be out of power, or you think you've just got enough, you've got a split second. I didn't mention these teams are racing it, even with the electric, maybe even faster, but 450 kilometers per hour, 450 kilometers per hour, 10 meters above the ground, with airplanes trying to pass you and get ahead of you, and you're trying to focus on the finish line. You've got tunnel vision. You've got very limited bandwidth for decision making. You don't want to have to be thinking, do I or don't I? Can I make it? Can I not? That's a very tough calculation that we don't want to, put into somebody who's hungry for the win. It absolutely is a human factor. So that's where, again, we're, the IRB, the auxiliary battery, as we're calling it, the reserve battery, is actually really an important part of that. And it's a very, very exciting, if I can say, maybe intriguing challenge to find. And is there a manual override and all these other questions that we're looking at right now? We've got a lot of the industry tendering right now, interested in providing those technologies. So, that is one thing, but it does go beyond that. There's judges. We disqualify people for aggressive flying. So it's not just the data that we take from the planes through the telemetry that we'll be aware of what's going on in the plane even before the pilot often is. That's a big part of it. But it's the conditioning and the qualifying and the rules and of the pilot and the self-discipline and the teams, et cetera, et cetera, et cetera. And we don't incentivize them. There's not a huge prize money for the winner and nothing for the loser. We don't want to add those types of variables in to amplify any human nature. So I don't know if that answers the question. It's an ongoing process that we'll be looking at for over the lifetime of the sport.
All right. And one more question in that direction, and then I'll kind of bring some questions together in one round. Question here, can you give us a feel of the pace of change in the technology? For example, what has changed in the time of getting the idea for e-racing, and where do you expect it to be at the first race?
Okay, I'll just say very quickly, and I might ask Ethan to elaborate, is when we decided to go forward with this project, the technology was and is, of course, in the market today. This can be done. Now, it can always be done better, and that's the nature of all technological evolution. It gets better every year, and we improve, and we will for 1,000 years. So it does change every year, and And perhaps maybe now that I'm thinking about it, it's kind of a good question, because we do get approached by a lot of manufacturers saying, hey, you know, our battery has this discharge rate and you know, these parameters and so on and so on. And actually those are kind of increasing every time they contact us. We kind of get someone that does it better than the last one. So that actually is probably an interesting evolution, even in a short period of time. And we get a lot of even companies like VTOL manufacturers that are interested in coming on board. It's not something I'd thought about initially, but you know, the same sort of power usage profile, data, you know, duty cycle, you know, is involved in VTOL. So there's a lot of other sort of thought-provoking ideas that come to us as well, which increase our knowledge. But maybe I should have let Ethan answer that. Ethan answered that. I don't know if you want to add to that.
Yeah, maybe to give some ideas more on a, I guess, practical note. I mean, there's, I guess, the biggest effect over the past 2 years has been not only, you know, like a percentage improvement over, you know, like efficiencies or components or you know, like technologies being developed for aviation, but I think the growth of that actual supplier market, since, you know, like because of the evolution on also and the interest on the eVTOL and urban mobility initiatives, I think a lot of suppliers are looking more closely at what electric aviation is going to be doing. Therefore, you know, like opening new lines of development for components for their particular, you know, like expertise areas, or even, you know, like full families of products that target the broader electric aviation. So I think that probably has had the biggest effect towards our sport, more than, you know, like any particular breakthrough in technology over the past, you know, like 2 years, 18 months.
All right. Then I have some questions on technology, which will come later, but I'll first give a round on more organizational things. So I'll spell out some questions all at once, and I think you can bring a story around that. So when is the next race, or the first race, going to happen? What's the duration of a race? What's the maximum altitude they're flying? Who are those pilots? Are these old F-16 pilots? How do you select those pilots? Do they need to have any prior experience and have electric flying experience as well under the belt? Another question in that sense? Let me just try and browse through those. It's a similar question. Yeah, let's stop with that one.
Okay, because quite a lot in there. I'll try to keep it concise. And by all means, interject if I miss one of those points. The first race is going to be at the end of next year. It's perhaps going to be a little bit more of a showcase race, you know, a test event, but it will be an electric airplane race. And then in 2022 is going to be the first series of races where the points will actually accrue over a tour, you know, over a series of races. So already starting next year. And between now and next year, we're speaking with several different airports around the world to be a test facility where we're actually going to be doing other types of activities. So test flights, race training, and things like that, both to get the planes ready and the technology ready, but also to introduce media and fans to what we do. So there will be other types of events along the way before that time. And that brings us to one of the other questions in there, was the pilot training. So we actually have what's called a pylon racing school. So pylon racing is a broad term for races with obviously racing around pylons, not the pylons that like in Red Bull they call those gates, but pylon racing when it's multiple planes racing around a circuit. There's a school and training that's ground school, several days. Now I say this, well, I was going to say there's several days of training and practical work and actual practice and a lot of stages of the actual qualifying of a race pilot. I was going to add that that's actually after they've already accumulated a number of hours, quite a number of hours in tailwheel time, in aerobatics time, formation time, perhaps display authorizations, things like that. That's not a requirement necessarily, but you know, we'd look to integrate that. So the teams do require a lot of other experience, but again, it's we can guide you through that process. So again, I encourage you to get in touch if you are a pilot or you want to develop a team, and we can take you through that whole initiation process. In fact, Ethan is the point of contact for that. And then in terms of getting those pilots and teams ready for the race, we also do some, it's not hand holding, but we introduce people to the different aspects of air racing and bring them along, help bring them along until we get to that first race, which again races ultimately will be held all over the world. So I don't know, Yuri, if I missed any points in there, any questions I didn't touch?
Yeah, there was one on, do you need to be an old F-16 pilot to fly that?
No, we do have some fighter pilots actually that do some of our races, and I'm referring to the Formula One now. We have an F-14 pilot, actually an F-18 pilot or an F-16 pilot, I think, as well. So we do have some fighter pilots, but actually, if you ask the Formula guys, they'll actually, and I don't mean to offend anyone in the audience, is what they say, that actually sometimes fighter pilots or heavy jet pilots don't make as great of an air racer as somebody coming up from more grassroots angle. So I don't know. That's I'm a pilot. I do a little bit of other types of air racing, but that's a very specific question that I could probably put you in touch with the governing bodies that do some of the more training with the pilots as to what the mindset is and who makes a good pilot and what their background is. But I will say this, they come from all types of backgrounds. Fighter jet, a lot of them are airline pilots, and a lot of them come from either aerobatics or just private flying, and they have day jobs and they're lawyers and teachers and mechanics and the like.
Okay, then I'll have 2 more rounds. So one here is on the technology. Do the teams own their technology, or is there an agreement between the race organization and the teams? And another question kind of linked to it is, how do you see Air Race E in the future? Do you expect that the aircraft design would converge to one model, like it was the case with the first air race type of aircraft, and the racing would focus again on flying technique? Or do you expect to remain it at a technology pushing industry?
Interesting question. Well, let me answer that, and then I'll jump back to the first part. If you look at sports, I mean, even in Formula One cars, I mean, the differences between the cars, at least to someone not in that field, are really minute. I mean, the formula is so tightly written. And that's only happened over decades of evolution of the sport for that to get so honed. So, a lot of people might say, oh, but Formula One's not even competitive anymore. It's kind of the same car. It's, this and that. You hear people saying that. And to me, whether it is or isn't, I don't know. But that's a great story. The fact that we found the natural perfection of something is the whole fundamental reason we do it. So, the first step is to get to that point of maturity of the technology where the planes do learn from each other and they copy and they compete and they get things done so that they can actually hone in on what is the best optimum, way. There may be not an infinite way of doing things. There probably are a few better ways of doing things. But that's when the next stage comes in, where actually we look ahead as to what the industry needs again, and how innovation, what level of innovation is going to be important, and what can we do with the rules, maybe make it open to distributed propulsion, whatever it is. There's lots of different ways we can develop this, and then it opens it up again, and new people have to start, new concepts and develop new technologies. We're going to be led by the industry on that. We want this to always have an application and a relevance to the aerospace industry. Fans are going to enjoy good racing. So that part of it's there. And I apologize, Jerry, what was the first part of that question? The first question.
Good question. Well, I can't actually remember.
Okay, well, forgive me if I missed that.
Yeah, I got already prepared.
Yes, now we're asking about basically, do the teams own the technology, or if there's transition? And maybe I can quickly ask that. So basically, because of the sport we built, basically the teams have complete freedom over the technologies they develop and the suppliers they choose. So IP is retained 100% by them, and they're happy to work with any suppliers that they want, as long as they meet the specifics of the rules in terms of performance and safety. Yeah.
Right, which leads us to the next series of questions. is how difficult would it be for an SME, so a small and medium enterprise, to take part? And another question related to that is, do you provide the service to link SMEs, so small and medium enterprises, innovators, with novel ideas to Airbus?
I don't know, Ethan, you want to talk about that? It's very team related.
So they can just, work
Sure,
with
yeah,
anyone.
absolutely. So, well, I'll say that, like the teams that are looking into, like putting this aircraft together are very efficient, but not very big. So, like for an SME to consider, like putting in a team or being a prominent partner of one of the existing racing teams and providing, like part of the technology or the operations or the financing, whatever it is, it's absolutely the right place to be. I mean, and if you research, I mean, some of the information on the most advanced teams is public. You can go to our website and check their approach to what they're doing. Some of them of these race teams are actually formed by small SMEs developing general aviation aircraft, and certainly is like the race we're putting together is the realm of SMEs and startups and like small teams that want to do innovative things. Absolutely.
Mm-hmm.
Which leads us to the next series of questions. Are electronic aids allowed for assistance, for instance, pilot assistance? And in combination with that, do the teams have the freedom to come up with exotic aerodynamic designs? And another question kind of related to this as well is, what budget would a typical team need to start the season?
Yeah, so maybe, Jeff, I'll start with the, I guess there was 3 questions there. So I'll start with the aerodynamics. So there is 2 elements that drive aerodynamics heavily within our formula, which are, there is a minimum wing area required, which is 66 square feet. And for the starting season, I mean, there is only one propulsion axis allowed, which means that you either have a single propeller or you have basically a twin propeller in a counter-rotating fashion, like with driving a coaxial shaft. So the freedom within that, I mean, it's limited but still big. So basically, whether you have a conventional like configuration, or you have a pusher configuration, whether you do canards, whether you a V-tail, you do a conventional tail, there's lots of freedom for the teams in there to explore efficiencies and advantages in performance. Absolutely.
Maybe I can add respond to the third question about the cost. I think it was about the investment level required to get involved. It certainly could be high if somebody wanted to make it high, but it's actually designed to be very low. So this is actually why it's another great reason why we picked the existing formula. The Formula One race planes are very inexpensive to build and to get into and to race. There's and in fact our company owns a couple of them that are for sale, and they're in the range of sort of 25,000–30,000 euros for a Formula One air race plane. Now the electrification side, of course, is more ambitious, more involved, and of course a lot more study, and you have to get new components and everything else. So that is greater than that. But it's designed to keep costs low for everyone. We didn't want cost to be a reason budget rather to be a reason somebody's winning or losing. So it's quite accessible. It's more accessible than you think. But importantly, we actually bring, as I may have mentioned in the presentation, is we bring partners, industry suppliers to the teams with really good deals, and we help negotiate that and get the best possible deals that are based on the specs that our teams want to see. So we're actually able to, as a group, in some cases, find really good deals in the market by exchanging it for promotion and kind of a sponsorship in kind sort of model. So actually, the teams have access to some really good, cost-effective, products and services, and we're here to help. So ultimately, if it wasn't affordable, we wouldn't have teams even line up at the starting line. So ultimately, we are very conscious of that. So we can tell you more detail in person if you get in touch with us.
All right, and I think it's about time to round up, but I'll pass on 2 more questions. In terms of building the infrastructure of the race itself, what are the biggest challenges? And then the last question is, what are percentages actually manually flown?
I didn't actually hear the last question. Could you repeat those questions? Sorry.
Yeah, what is the percentage of manual flying? Put it this way. Are the aircraft flown manually, or is there any form of autopilot in there or whatever?
At the moment, to my knowledge, they're all manually flown. Ethan, have you had other conversations?
Yeah, I would say manual 100%.
Mm-hmm.
Yeah.
And the first question was, what is the biggest challenge actually for building the infrastructure for the race?
Okay, so the infrastructure for the race, I guess, is there's a couple of ways. I mean, you know, we've talked a lot about the kind of infrastructure of the teams and aircraft themselves and the charging, and that's kind of its own thing we've talked about. The building the race itself, and now that's our domain, and that is what we do, and we're very good at it. Having done it, I mean, if I could say so, we are the world leader in air racing organization and promotion. Obviously, Red Bull, of course, has done amazing things, but they're not at the moment in the market. But in terms of multiple plane air racing, we're the only, you know, organization that's been doing that around the world outside of the Reno air races themselves for 15 years. So we have expertise in that. So we're really good at it. But it does require quite a bit of effort. You know, first of all, it's a large scale public event. At the air racing events, we're expecting 50, 100, maybe more 1,000 people, you know, tens of thousands of people. That itself is a big ask. And we work with the cities and the airports really carefully because our events are held at airports, fundamentally for safety reasons, but also for kind of messaging reasons. You know, we talk about Formula E, the car races, they do their races in city centers because that's where the pollution problem is the greatest and it brings home the message of what they're trying to achieve. For us, it's the same. So we do it at airports because we want to bring that message to home to the airports and showcase what airports are doing to help resolve these issues of, you know, of dirty aviation. And they're doing a lot. So we want to shine a light on that. So the airports themselves become important partners and participate with us on that infrastructure. They help manage the crowds and provide the airport and the access. And we work on the regulatory side, of course. Perhaps there's some people in the audience that come from the regulatory side. That takes some work, but of course we're very well practiced in those aspects of it. So we work on that. And then physically, you know, the airport's already there. The race is, you know, not far from the, you know, you could see the whole race. So it's really just becomes an infrastructure question of how, you know, do you want grandstands? Do they not? Do you want tents and food or not? You know, it's just kind of a public side thing. The air racing part is we've got it down to a system. Perhaps an overly long question, or sorry, answer for that question, but yeah, it's great. I encourage everyone to come out and see for yourselves what the infrastructure looks like. It'll be fun.
All right, then. So I can also say a name of the people who responded here or put their questions in the box. Many of the things were actually also thanking very much for the presentation and for the answers. So thanks again there, Jeff and Ethan, for making this happen actually and coming out by means of saying virtually in this way with a presentation on Air Race E, which is new to all. I think we'll all look forward to see these races come closer and enjoy it. As some say, that there may be quite a difference between a nice Merlin engine and what we'll hear down there, but I think the excitement will be not smaller anyway, in no way. So thanks all for every participant for joining us here in this first webinar. I hope the tool itself gave you all what you wanted. So the microphones were able to be used, but not sure why people didn't. If this was a technical reason or an emotional one. Anyhow, the questions came through anyway, so I hope everybody was served with good responses. If I missed any questions, my excuses for that. Before you leave, I will launch another poll, so if you could just answer the question there before you're off. So would you consider air racing as being relevant to the advancement of electrification in aerospace? So that's a poll we will be leaving you with. We thank you all for joining and look forward to see you next time around.
Thank you, everyone. Yeah, thanks very much.
Thank you, everyone.
Yeah, great pleasure.
Thank you. Great presentation. Thanks.
Thank you. Thank you. Hope to see you all soon in person. Goodbye.